Hello, students of St. Patrick's. My name is Jason Quiroga, and I'm an engineer here at Blue Origin. Let's go inside and see what I do.
I work on this. Can you guess what it is? It's 5 stories tall and has been to space. How about this? What do you think it would carry? So what does Blue Origin do? Well, here you can see a whole bunch of pictures of all the projects we work on. Starting from the left, we have our New Shepard rocket, which is a smaller rocket we use for several purposes. First, we use it to send tourists to space. The capsule on the very top of the rocket sends a crew of 7 astronauts all the way up to space, where they get to float around and look out of the windows for about 5 minutes, and then they come back down to Earth. We also use the New Shepard rocket to send scientific payloads, or science experiments, into space, so that universities and schools and scientists can research things like zero gravity, or what it's like out in space. This rocket also serves a purpose of testing one of our rocket engines, called the BE-3 rocket engine, which I'll talk about later. In the middle, you can see 2 pictures. The one on the top is a prototype of our lunar lander. One of the projects we're working on at Blue Origin is to land astronauts back on the moon. On the bottom, you can see a picture of our space station called Orbital Reef. And what Orbital Reef is it's going to act as a bus between the Earth and the moon, because we want to send astronauts to live and work on the moon all the time. Then, all the way on the right, you can see a picture again of the New Glenn rocket. That is a rocket that's currently under development here in Florida. It will be about 30 stories tall, so as tall as a skyscraper, and will launch really big payloads or really big satellites into space. And in the future, we'll launch astronauts too. So, do you want to ride on a New Shepard rocket? Let's watch this video so you can see what it's like.
Please make your way to the hatch.
Flight Astro. Astronauts are ingressing the cabin. Copy.
Now, wasn't that exciting? Let's talk about what I do specifically. As a design quality engineer, I work on the BE-3 rocket engine, which stands for Blue Engine Number 3. That's the type of engine that you just saw work on the New Shepard rocket. And what do I do as a design quality engineer? Well, we have 3 roles: check, inspect, and investigate. As engineers, we make a lot of drawings for components. That's the step before you go to manufacture the pieces in the factory. As a design quality engineer, we have to make sure that all of those drawings are correct, that all the holes are in the right places, that all the parts are of the right thickness, that everything's made of the correct materials, and that everything meets all of our standards. That's the checking step before manufacturing. Then the inspection step comes after manufacturing. Once the part is made here at the rocket factory, we have to make sure that it was made exactly like the drawing says it was supposed to be made. So we do a step called inspection, where we use all kinds of fancy tools to make sure that the part is exactly as we designed. And that way, it should work perfectly during flight. Rocket engines are really complex machinery, which has to endure all kinds of crazy temperatures and all kinds of difficult environments. A rocket engine starts off at negative 400 degrees Fahrenheit when it gets filled with really cold fuel called liquid hydrogen or liquid methane. Then, once the engine is ignited and it launches a rocket into the sky, it can get to over 6,000 degrees Fahrenheit. So those engines have to be made in a way that it can endure all of those changes in temperature and pressure. They have to be made really well. If we did all of our jobs right, the rocket works perfectly like you saw in the video. Sometimes mistakes can be made and accidents happen. Then that leads us to the third step, which is to investigate. If something goes wrong, we need to know why that is. So, since we were the people involved in making sure that everything was right in the drawing and right on the floor, we are involved in an investigation in the event that something goes wrong so that we can learn from it and make sure it doesn't happen again. What does it take to become an aerospace engineer? Well, there's a lot of studying involved. After all, it is rocket science. Here's how I did it. First, let's start with a little bit about my education. I went to St. Patrick's from preschool to 8th grade. I graduated in 2010. Then after that, I went to Immaculata LaSalle High School, where I graduated in 2014. For college, I went to the University of Central Florida, where I got my bachelor's and master's in aerospace engineering. Aerospace engineering is a branch of engineering that deals with rockets and rocketry in specific. So as an engineer, what school subjects do I use every day? First is math and science. In order to make that rocket fly, as you saw, it involves a lot of complex equations to make sure all the pieces of that rocket work together in order to achieve that result. Math and science come together to form another branch of science called physics, which you'll learn more about in high school. It's the study of objects in motion and of other natural phenomena, and we use that all the time in engineering. The next school subject that I use all the time is my computer skills. Computers are really important tools in engineering, and we use them every day in order to solve really complex equations that we can't do by hand. Additionally, we use computers to also simulate rocket flights and machine very complex components. So computers are a really, really important part of what we do. The third subject might come as a surprise. It's actually writing. Even though in engineering we use math, science, and computer skills all the time, every day, writing is a very important aspect as well, because you need to be able to communicate your results with other engineers and the managers and all the other team members you have to work together with in order to get the rocket to fly. It's just as important as being able to do those complicated calculations. So what kind of personal skills do you need as an engineer? First is problem solving. As you can imagine, in engineering, you're solving problems every day about how to get components to work, about what to do if they fail, all kinds of problems like that. And in the world of aerospace engineering in specific, some of those questions are really complicated and they've never even been solved before. We're the first ones trying to do it sometimes. So having an attitude of problem solving is going to be very, very important. Next is commitment and determination. Sometimes these problems can get really hard and it makes you want to leave the project. But if you're committed and determined, you stick with it and see it through to the end. Next is teamwork. At Blue Origin, we have over 11,000 employees, each making their contribution to the thousands and thousands of parts that go into making a rocket fly. In order to be a successful engineer, you have to be able to work as a team, because together as a team, you'll be able to solve harder problems than you would by yourself. Lastly is humility. Humility is very important because it's when you know that you can't solve something on your own and you can reach out to your fellow team members in order to help you. Or if you do something wrong, your teammates can help you point out what you did. And that way, you'll be able to get to the correct answer and avoid a failure in the future. That's how you build a stronger team. Here is what our teams at Blue Origin are working on now for the New Glenn rocket. This is what we call the first stage of the rocket. That's the part that holds the fuel and the engines that launch the rocket into space. This is that first stage being rolled out to the launch pad for testing. This part on its own is actually a foot taller than the Leaning Tower of Pisa.
Alright, now we're here on the balcony of the rocket factory, so I can show you some of the sights. Over here you can see the Kennedy Space Center Visitor Complex, where you can come tour and see a whole bunch of really interesting rockets from NASA and a bunch of other companies. Down this way is NASA's Vehicle Assembly Building. That's where they built the Saturn V rocket and the Space Shuttle and a whole bunch of really interesting rockets. Down this way you can see OneWeb satellites. They manufacture satellites that go to space. And down this way you can see Launch Complex number 40. That's where SpaceX launches a whole bunch of their rockets, almost one a week.
This is a closer picture of Launch Complex 40 with a SpaceX rocket ready to launch. Let's watch. Here's a video a friend of mine recorded.
Don't you feel the light below it though?
There it is. Yep. Starting up, starting up.
Whoa.
The rocket you just saw was a SpaceX Falcon 9 rocket, like the outlined picture here. Next to it is Blue Origin's New Shepard rocket, like the one you saw earlier, and NASA's SLS rocket that they use for the Artemis program. On the right are two rocket models in development now, including Blue Origin's New Glenn rocket. The road to space is difficult and requires hard work and innovation, but it is a road like no other. I chose this career path when I was very young, inspired by meeting Mike Mullane, one of the Space Shuttle astronauts, at Kennedy Space Center's Visitor Complex. I followed my dream and even ran into him again recently at a Blue Origin event. Thank you for listening to my presentation. I hope that you enjoyed it and that it can encourage you to become our country's future engineers and even astronauts. Thank you and God bless. Bye-bye.